talk about mitosis and meiosis. As I said in the previous video, mitosis was the way that body cells divide, and meiosis is the way that gametes divide. Gametes are sperm and egg cells, basically. First of all, in mitosis, there are 4 phases: prophase, metaphase, anaphase, and telophase. So, before mitosis, and it actually happens before meiosis as well, is interphase. So the cell grows, performs its cell functions, and replicates DNA. The way DNA is replicated goes as follows. First of all, enzymes split the DNA strands. And DNA has 4 bases: adenine, thymine, guanine, and cytosine. Cytosine and guanine stick together, and adenine and thymine stick together as well. So that means that when enzymes split, new base pairs pair on each DNA. So then you have identical DNA. Now we can get into mitosis. In prophase, the chromosomes are thickening, they're condensing, and they're becoming visible. The nucleus is still there. It's going to be disassembled later, but in metaphase it will be disassembled, but it's here for now. Then, in metaphase, we say goodbye to the nucleus because it will get disassembled, and the chromosomes line up in the middle. Then, spindles attach to the chromatids. Now, the tricky part is that we tend to count the chromosomes by the number of centromeres present. So, 1 centromere is basically the center, where the 2 chromatids attach. So that basically means that when you replicate in interphase, so there are 46 chromosomes, and they look like little sticks, but then when you replicate, you still have 46 chromosomes, but you double the amount of chromatids to get 92 chromosomes. And that's really difficult, because basically, when you take 46 and double it, you get 92. But if these chromatids weren't attached, you could basically say there were 92 chromosomes. So there are 92 chromosomes, but there are 92 chromatids and 46 chromosomes. In anaphase, the chromatids are pulled away from each other. They move to opposite sides of the cell. Then in telophase, 2 new nuclei form. 2 new nuclei, then cytokinesis splits the cytoplasm, forming 2 identical cells. In meiosis, it's a little different. It's a reduction division because the original cell, and actually in mitosis and meiosis, after that, the parent cell doesn't exist anymore. So now it's 2 identical cells. So mitosis is great for repair of damage and growth. Meiosis helps so that fertilization can occur. The way this happens is that gametes have 23 chromosomes because when an egg and a sperm come together, it becomes 46 chromosomes. 23 plus 23 is 46, so it's 46 chromosomes. That helps a fertilized egg become a human. So what happens is that the fertilized egg does mitosis, and not meiosis, to split itself into a human. Meiosis contributes to the spice of life. And what happens is that you have the original parent cell that has 46 chromosomes, they divide, it's 23 chromosomes, 46 chromatids, then it divides again, 23 chromosomes, 23 chromatids. So it's basically that it divides twice. So you're going to do the phases for mitosis, but twice. So you put numbers in Roman numerals to represent which division we are, the first or the second. So let's take a look at prophase 1, metaphase 1, anaphase 1, and telophase 1. In prophase 1, the nucleus is still there, like always. It's kind of like mitosis. It's pretty much the same thing. Then homologous chromosomes line up. Homologous means that they have about the same size and have the exact same genes in the exact same spot. They can have this process called crossing over, where they exchange genes between each other. They exchange the genes between each other, basically. Metaphase, the chromosomes line up, but they're in 2 phi lines. The homologous pairs go next to each other. Then the homologous chromosomes, so I'm 1 chromosome, and then someone else is here, we move away. And because we were homologous chromosomes, then we move away, basically. Imagine that, okay? You are a chromosome, and you have an identical twin next to you. Then spindles move you two away from each other. That's basically how it is in anaphase 1. In telophase 1, two new nuclei form, and then cytokinesis splits the cytoplasm. In prophase 2, it's just a chromosome. It's the same as in mitosis. Then in metaphase 2, there is single file. They line up in the middle and are in a single file line, just like in mitosis. Then in anaphase 2, the chromatids move away. Then in telophase 2, two new nuclei form around both of those cells. Then cytokinesis splits the cytoplasm of the two cells. That basically means that in meiosis, the second division is the same as mitosis, but the first division is different than mitosis. That's the key. So that's how cells divide. Well, that's it for making math easy, and remind you to stay curious in math and science.